They say university makes students. Here, students make university. So with the slogan of Think Big, I, Himanshu Kaushik, your host of the day, would like to welcome you all in today's webinar slash seminar on current trend in chemistry. And I hope that you all are doing good, safe, sound, and happy at wherever you're taking this session from. So before we move on and learn a lot more about the opportunities we can have while studying this specific subject, that's chemistry, we are having our expert here who has joined us. So please welcome Dr. Suman Maji, who has done his PhD from IIT Kanpur and is currently a professor in School of Chemical Engineering and Physical Sciences, of course, in lovely professional university. He's having more than 14 years of experience in teaching and has worked in various institutes, and he has his interests in synthesis of inorganic and organic compounds, handling of moisture and air sensitive compounds using standard clean line technique and glove box, NMR, EPR, UVIR, and there are many other analysis techniques that he's already used, and he's having various interests in other fields, for example, kinetic study using stock flow methods as well. And not only this, he has qualified a national eligibility test, that is CSIR net, in chemical sciences in year 2000. And after that, he also has qualified GATE in 2000. And then he was awarded with postdoctoral fellowship from Academia Sinica in 2008. And last but not the least, he's already having 25 plus publications and has been a part of various conferences and seminars of national and international repute. So today he will be here to provide his assistance, his guidance, and would help us to know what are the current trends of chemistry and what all opportunities we can have while studying this topic. So with, yeah, so with this, I welcome you in the session here, and over to you, sir.
Sir.
So we can start, yeah.
Yes, thank you very much, Shima, for your kind introduction. We are here today for this webinar in current trends in chemistry. Chemistry is a very vast subject, and there are lot many things which are happening around it throughout the world. So how we are getting impacted with these current trends or these innovations which are happening in chemistry. So this is just a short glimpses. These are some short glimpses of what are the new innovations that are happening around us. Okay. So I will take you through this. So when we talk about chemistry, everything depends on energy needs. So the first thing that I want to discuss with you is how the chemistry is helping in procuring greener sources of energy. We all know about these greener sources, which are the wind energy, solar energy. But nowadays, we are also having other cleaner modes of energy in the form of hydrogen-based fuels, or we can say the hydrogen fuel. But we are also talking about energy production from hydrogen as a source or as a fuel. In addition to this, if I talk about solar cells, we all are aware about solar cells. Everywhere we see these solar cells, but most of these solar cells have very low efficiency. Working on how to improve the efficiency of these solar cells. So a few of the innovations in this field will be the organic cells. Okay, nowadays most of the things are printed in on the chip. Okay, so we have organic dyes which are printed, organic photosensitive materials which are printed, which absorb the solar energy and convert it into electricity. And this actually makes the system much more efficient. Some of the questions at the end of the session, maybe. I see someone is raising hand. So I'll be taking a few questions at the end of this talk. So when we are talking about this energy systems, as I was mentioning about solar cells, so organic solar cells are there, which are printed. In addition to that, the new invention or innovation in solar cell will be the perovskite-based solar cells. Okay, so these are much more efficient and they convert much of the solar energy into electrical energy. We are into the future where we will be looking into innovations in our building technologies also. But how this building technology is related to chemistry? It's related to chemistry in the form of the materials that we are using for the building. I think soon we will be using materials which are smart and which are much more efficient. Like we are using glass universe, right? Which is transparent. So soon there will be the solar cells will also be converting some portion of the sunlight into electricity. So these kind of new innovations are also coming into our way. And by the way, as we are talking about LPU, I just want to give you one information that LPU also has more than 5 megawatts of okay. So the next thing which comes into my mind is biodegradable materials. Why we are talking about biodegradable materials is it directly connects with our environment. Nowadays, we all are talking about environment pollution. We all are talking about plastic pollution, and a major nuance of these plastic pollutions is the microplastics. Okay, so all these plastics that we are use, we know they are not degrading easily, and once they are in the environment, they are diffused into the ocean, where all the living organisms are facing this issue. Okay, so why not make plastic which is biodegradable? So how we can make it? Chemists have done it. There is one material called shrill. Shrill is actually made up of shrimp and silk. Okay, so you know shrimp is have a outer exoskeleton. Okay, so this exoskeleton in shrimp and in many other insect is made up of protein chitosan. Okay, so scientists have developed a composite with this chitosan and a protein which is collected or which is also present in silk, the fibrin proteins. Okay, so this fibrin protein and chitosan composites is called this new material called shrill. Shrill is as tough or as light as shrimp. It is 50% lighter in weight. Moreover, as this is made up of biopolymer, so when it degrades into smaller pieces without
Sir,
nowadays we are also seeing
sir, I'm very
lot of
sorry
these
to interrupt.
biodegradable materials
I'm very sorry to
in
interrupt,
in the form of
but you're not audible correctly. I think there's lag in internet and you're not audible correctly, sir. So can you hear me? Am I audible? Students, attendees, can you all please respond in the chat box or in the Q&A box? Am I audible to you all? everyone? If anyone can write in the chat box, am I audible? Are you all able to hear us? Okay, I think yeah, Nilima, you can hear. Okay, Priyanshu, you can hear. Okay. I think there was some internet issue with the server's end and he got disconnected. Meanwhile, I just want you all to write your questions if you have any, and the query if you have any in the chat box. And if you want to ask anything, if you want to have a discussion on anything, just kindly write in the chat box or Q&A box so that we can ask our expert directly. And meanwhile, you all can tell me, how did you like this session till now? Were you all able to hear that properly? I mean, was sir's voice clearly audible to you all? Anyone who can answer me in the chat box? Okay, so sir's voice was clearly audible. Nilima says yes. Priyanshu says, okay, not mine, Priyanshu. Sir's voice. I'm just asking. Earlier, when the session was going on, was it just me? The voice was audible. Okay, it was. Okay. So, may I ask Maliki, Mohammed Alamin, Nazma Naik, Rahul Bansal to also reply here, Ravi Kumar, so that I know. Yeah, okay. I got it. So meanwhile, you all can tell me if you have any query. I mean, you can just put up your query in the chat box. Anyone who wants to have a discussion can raise the hand as well. Yeah, sir has joined, I believe.
Hello.
Yeah, you're audible, sir. You're audible.
Okay.
Yeah.
So I'm sorry, there might be some network issues.
No issue, sir.
Okay. So we were talking about this. Now, am I audible? Okay.
Yes, you're
So we were
audible.
talking about these plastic materials and the packaging materials which are now coming. See, these chemists are also coming up with packaging materials which will be edible. Edible means we can eat them. These will be made up of mostly rice and some other materials which from the main polymers will be collected, or the biopolymers will be collected from this kind of materials. Okay. We are seeing certain alternate materials also, like some leather like materials which are converted out of pineapple leaves or some other bio-based materials. Okay. So how we can upcycle the waste? So it's not about the environmental issues that we need to talk about. When we talk about environmental pollution, we also need to take care of the waste material that we are generating every day. So how we can use this waste material for the benefit? Okay, so that is also an important avenue that we must venture into, and the chemists are working on it. And here I just want to give you one example that we were doing in our group specifically, that you all have heard about polystyrene, right? Polystyrene is a polymer which is used mostly in the packaging material. And after the package is uh, transferred, these white uh, beads or the white materials are actually thrown out in the garbage, and they do not degrade easily. So what we did was we used these polystyrene materials into converting them into porous concrete, which we can use as pavement materials. Okay, so these are some of the innovations which we are doing throughout the world, and at LPU also we are part of it. So how the chemistry field is getting transformed with the newer technologies that we are seeing nowadays. We all are aware of artificial intelligence or AI. So how AI is going to impact, or how AI is impacting the chemistry domain, is that the machine learning process. Okay. Machine learning process is something which uses the neural network type of connections, and it actually gets the data from the physical environment, converts that data into a digitized form. Now, that data is processed through the AI, and the outputs are calculated, okay, based on certain algorithms that the AI are using. So outcomes will be calculated, which will again will be converted from the digital form to the physical form through different processes. Maybe some IoT based components will be there which are directly talking to the web based servers. Okay, so all these things are actually helping in transforming the industrial process. Mostly in industrial process, you know that some of the times we have to use hazardous materials also. So automation will be there where the robots will be transforming or transferring these hazardous materials. Then we have the optimization process. So AI here can predict the conditions, the reaction conditions, which will give us the optimum yield of the product with minimum of the wastage. Okay, so the impact of the AI can also be felt where the all the databases that we have created so far with so many experimental experiments that have been done in this field of chemistry, and how we are converting that database into some useful information. So a major part in this is in the pharmaceutical industry, mostly in the drug designing. So how these drugs are designed nowadays is based on, again, certain AI tools. So if I talk about this virtual screening, so there are certain programs or processes in the computational processes which are actually looking into the protein structure. Okay, once you feed it with the amino acid sequence of the protein, it will calculate the protein structure, the three-dimensional structure of the protein. It will calculate where are the folds in the protein structure. And based on that fold, it can actually generate an artificial ligand. Okay, so it can give us information that this kind of molecules will fit into this protein group, which can actually alter the functioning of the protein. So for that, we do not have to synthesize the ligand. We just have to feed all the information into the computer. And from there, we can get the suggested list of molecules. We can then synthesize those 10 molecules rather than synthesizing 100 molecule and then screening through the protein. We can take the help of the AI and just synthesize maybe 5 or 10 suggested ligands and then directly test them on the protein. Drug delivery mechanisms are also changing nowadays. Drug delivery mechanisms are improving because it actually helps us to transfer the drug molecules at a particular location where it is needed. Okay, so rather than wasting the drug throughout, distributing it throughout our whole body, we can pinpoint that drug molecules into the location where it is needed. Nowadays, we are also working on DNA technologies, how the DNA are cut and new informations are fed into the DNA so that we can fight the newer diseases in much better manner. So here also AI can suggest the locations where the DNA must be manipulated or some new fragments must be added. Okay, so these all are certain innovations which are happening and they are impacting the industry as well as the academic. When we talk about the industry is rapidly changing. So we had seen industry 1.0, 2.0, 3.0, and now we are into the 4.0. 4.0 is nothing but where we are seeing interconnectivity of all the components which are connected through web. Okay. And also, most of these are controlled by AI. Okay. So when we talk about a chemical transformation, we all know the basic of chemistry is that a catalyst might be helping in making the reaction faster. Okay. So nowadays, much of the focus is on making different types of catalysts which will be reacting in much more efficient manner, okay, giving us the products. The reactors are also changing. We do not work with kilogram. We do not have to work with kilogram or phase starting materials. Now we have micro reactors. In micro reactors, you can easily do the reaction with very little amount of the reactant producing very less amount of waste material also, needing very less amount of the solvents also. Why? Because all these waste material or the solvents do impact our environment. So we have to look for greener methods of synthesis using chemicals which have lesser impact on our environment. Okay. So in this field, some much of the work is going on in photocatalysis, so light-based catalysts, okay, where light can be activating the catalyst. We are talking about click chemistry. Okay, so these are few of the things which are happening around the world through the industry. And the outcomes which we can already see, as I have mentioned about the hydrogen fuel cells, we are talking about newer technologies in not only energy production, but also in energy storage. Newer forms of batteries are coming up. Initially, we were all aware about the lithium-ion battery, but now lithium-ion batteries are also replaced with sodium-ion batteries. Sodium, which is much more easily available and have less toxic effects or less corrosive effect. Okay, so here are some of the outcomes of the newer trends or the new inventions that we see in chemistry. So if I have to summarize that, what is the future direction in chemistry or mostly in the field of chemistry research, we can say that we have to find the global challenges. Okay, we have to find the new frontiers, like as mentioned here, quantum computing, and there are many, many other newer forms which we must consider when we take the challenges which the ultimate goal will always be um, like artificial life. Okay, we are talking about robotics, we are talking about AI, so maybe at some point of time we will also be talking about artificial life. So uh, I think within this very short time I just try to uh, collect or compose some of the new things which are happening around chemistry. And in doing that, I just want to add a few things like we at LPU, what we are doing at Lovely Professional University. So as Himanshi ma'am has already told you, I'm a professor in the School of Chemical Engineering and Physical Sciences. And what we are doing here in the school is we offer programs in the undergraduate, like some BSc programs in the chemistry, physics, and math. And also we have BTech program in chemical engineering. We have postgraduate programs or the MSc programs in chemistry, physics, and math and stats, and also the doctoral program. Now, we should why or what is the outcome of these programs? Here you can see some of the students who got selected into very good companies, and these are some of the companies where they got selected. Our students are also working on their own ventures. Here you can see our students who have developed their own companies. The students are going into research. We are talking about new research methods or new research ideas. So our students are also working in different universities. they go for short-term projects or visits, or they are working there in the PhD programs. Okay, here you can see some of the research scholars also who are getting uh, uh, acclamations. Okay, so our BSc students are also not only our research scholars who are publishing very good journals. Our BSc students are also, our MSc students are also publishing in good journals. Okay, so at LPU we focus a lot on these research uh, facilities. We have very good research facility here at LPU. We have uh, trained teachers, we have professors with very good research profiles who are helping the students or who are guiding the students for publishing papers in very reputed journals. We have projects also. Here is some information about LPO. We have very good infrastructure or the instrumental facility also to support the kind of research that we are doing here, right? So this is in short my presentation. So thank you all. Thank you, Himanshi ma'am, for giving me this opportunity to talk about the chemistry, a field which I love.
Yeah, thank you, sir. I think it's our pleasure to be able to listen you and to get the guidance of the topic and of the stream specifically. So thank you so much, sir, for coming in, crediting your time for all of us here. And
Thank
so
you.
just one question that I was having. So, for example, let's say somebody who has done BCom, okay, like different stream from science altogether, and wants to enter or wants to do masters in chemistry, or let's say anything specifically under this particular stream. So, would it be possible for them? And if it is, then how hard or how easy it would be for them to transit from a specific, I mean, non-specific to a specific field?
See, for the master's program, there are certain requirements that the student must have gone through certain courses. So it doesn't matter if it is BCom, but if he has those courses in their curriculum, wherever they have done their previous degree, if those basic courses are there, they can do their master's. Okay, there is no issue in that. And if you talk about the difficulty, see, as we go higher in the study, things will be definitely getting advanced. But at the same time, your understanding is also getting better and better. So I won't say it is difficult, but with time, I think you can easily manage those things. So it will not be very difficult if you are pursuing, if you're giving it time, actually.
Right. And sir, if let's say somebody has transited from BCom to chemistry and they've done it and they've studied it. So all the opportunities and trends that you've told in the session here would be for them also, or would it
Equally
be,
applicable,
yeah,
equally applicable. Because it depends on, see, how you are applying your knowledge, even in BCom or in your sciences, if I can talk about, because they can shift to any of the sciences, chemistry, physics, maths. It all depends on their own interest.
right,
Okay, so if they are interested in that specific field, you will obviously gain knowledge. There will be obviously some hand holding with your seniors, with your professors, okay, who are who are going to help you to cross those hurdles. Okay.
right.
So we should not actually start by thinking about the hurdles. Rather, we should start with the what are the results or what are the future that we see in these fields. So
Right.
here I just wanted to capture some of the future trends which might be helping you to decide.
Right. So thank you so much.
Thank
And
you.
with this, I just want anyone, I mean, any attendee who has any question can post in the chat box. And if not, then sir, I would like to take your permission to wrap the session up here. So
Yeah.
attendees, if you have any other question, you can write in the chat box. And if not, then you can just maybe write yes or no in the chat also, that we can confirm you're not having any query, question, or any discussion related to chemistry or the related field. You can have it here. And I think so we're done with the questions now. So with
Okay.
this, sir, I would like to thank you again for coming in, for joining us here. And at the end, I also want to thank all the participants, attendees who have come here, who have joined us and stayed for this, this session. So maybe you come here, you visit our university, and you get to learn from experts like Suman sir and various other experts as well. And if not, then of course we're gonna see you next session virtually. And until then, stay safe, stay healthy. Thank you so much for joining in. Thank you.
Thank you.